Hello and welcome back. So what I want to do in this video is just revisit some of the concepts that you just learned about in the video with Claudio, thinking about different kinds of types of interactions and also the evidence for them, particularly the evidence for competition or non-competitive interactions within herbivores, but just flesh those out a little bit, revisit the definitions of those, and give you some examples to kind of help some of these concepts stick a little bit. So if you're super familiar with these, you can feel free to skip through this video or watch it quickly. So when we think about the different ways in which members, either species or individuals within a trophic guild might interact, including compete, we can think of this in happening in a few different ways. So one, in some sense, maybe the most straightforward way two species that are potentially occupying a similar niche or feeding on the same thing might interact is through direct, what we call interference competition. So this can involve, and this is really any case where there is, again, a direct interaction between the two sort of participants, species, again, or individuals. So, for example, aggressive territorial fighting behavior is often an example of this sort of interference competition, but it can also happen at the sort of community scale in lots of different really interesting ways. So here's one example that I like in stem-boring insects with Spartina grasses. So there's many species here that will, basically their larvae develop inside the stem of these widespread Spartina grasses. And so that's kind of a constricted environment. There might be, the space itself for developing might be kind of a limiting resource. And so in this system, it turns out there are a lot of different species, again, that can occupy these, and they directly affect each other. And in particular, one of the dominant species, this moth, can directly attack, and many of the species will do this to each other, but they actually directly attack and kill, often through piercing by piercing right through the soft cuticle of these developing larvae, and they don't consume the other species that they kill. They just kind of incapacitate them. So it's not predation. They're not getting a nutritional benefit. They're just taking out this other species and sort of fighting over space. So again, an example of a direct negative interaction, again, that we call interference competition. And that's distinct from what we might think of as, in some sense, maybe classical competition, which is fighting over a resource. So where the negative effect on one species happens through consumption of a limited resource. So especially if there's not enough resource to go around, basically the resources, the food source can become limiting for one or the other species. And this is called exploitation competition, or you also hear the term scramble competition, which is maybe a good way to remember it. But there's a nice example of that with this blowfly. Some older experimental work showed that basically if you artificially manipulate the density of the maggots of this species on the same volume of flesh or carrion where these larvae would develop, at low densities you get very high survival, but pretty quickly at higher densities you actually get no adult emergence at all. So sort of rapid decline of the available food source, and therefore total zero survival and successful development in the species. So again, an example where there's sort of negative effects for everybody when and direct negative interfering or competitive interactions leading to impaired outcomes. So again, difference, interference competition being direct interactions within a trophic guild, exploitative competition and scramble competition being fighting over a limited resource. And so in some sense mediated by the resource. I'm going to skip ahead to this one other kind of competition or competition-like phenomenon, which is called apparent competition. This is a really interesting version of this. And this is where instead of thinking about, there's a limited resource, where there might be, you can think of it as kind of a trade-off between, if one species is doing well, that's sort of bad for the other species. You can actually get similar dynamics, but that are mediated by a predator or an enemy. So this is something we call apparent competition or enemy-free space. So what can this look like? This is an example from actually a paper that you're going to read for your required reading for this week. And this is where there are two species of leafhopper consuming that are sympatric, so live in the same area, although one's invasive. You can read about this case a bit more, but they're both parasitized by a single parasitoid wasp. So in this case, what can happen is, if you can imagine think back to the Lac-Volterra equations, these sort of coupled dynamics between prey and predators. One thing that can happen is if one species, if your prey species is doing well, that can increase a predator or parasitoid population, and that parasitoid can then also have negative effects on these other species, right, that are also predated on. So in this case, there's a negative interaction between these two parasitized species, right? So it sort of looks like competition, but it's actually mediated through a predator. So we think of this as sort of competition for enemy-free, the ability to free yourself from potential enemies. So again, apparent competition. And so all of those, really what we've focused on a lot and we've heard a lot about already in the materials for this week are negative interactions and especially competitive dynamics. And there's been a lot of focus on sort of competition, limited resources in the literature writ large. And again, you heard a little bit about the sort of ebbs and flows over time of how important we think competition is, particularly in herbivores. But in some ways that can obscure the importance of, and actually how common a lot of very positive interactions between species can be. So one example of this is facilitation. So in general, if we think about here, an effect or a relationship between herbivores that's sort of mediated by the plant, that can be positive or negative. So you can imagine, for example, cases, or you might have read about in your textbook, some examples where if you say alter the plant resource, not in quantity but in quality, that might have a negative effect on another herbivore. But there are also examples where the presence of one herbivore can encourage other herbivores. And so this is one cool example of this is the leaf tying moth that makes its home in oaks by actually tying two leaves together, sort of weaving them together, making a little shelter and microenvironment that it itself uses to sort of promote its own growth. But one of the cool things is after it makes these leaf ties, that actually encourages lots of other species to join. So this is some cool experimental work from a couple decades ago where they went and both removed and then sort of recreated these leaf ties. And what they found is that there were persistent effects across the season. So basically in these leaf ties, you had an accumulation of different kinds of species that showed up on these sort of tied together oak leaves. So basically what this one, it's really sort of an ecosystem engineer. This one species is changing the environment in a way that encourages colonization and persistence of other species. So again, one species is facilitating the sort of colonization and success of another species. So a positive interaction. And we're actually going to start after this week. A lot of what we're talking about in this week's materials is the different kinds of competition, but next week we're going to start really diving into positive interactions and in addition to coevolution, but we're going to talk a lot more specifically about mutualism, so where there's often tight coevolution between partners that have mutual benefits. But in general, I think one of the takeaways is this traditional view of, there's these really common negative interactions that are driven by direct interactions between competitors is really limited. There's a lot of different ways in which species interact. They're very complex. They're often mediated by third parties, either the plants or these predators, and also there's a lot of often positive interactions. So basically these webs of interaction are really complex, and that's going to set the stage for a lot of what we actually talk about for the whole rest of the semester.